Welcome back to Miss Eddie's Math Movies, where it's a cube to be a square. Today's lesson is 9.6, Volume and Surface Area of Spheres. By the end of the lesson, you'll be able to find the volume and the surface area of a sphere. A sphere, maybe you've seen before, is like a ball, a basketball, a volleyball, a softball. It is, in its formal definition, is the set of all points in space from a distance called the center. Well, the same distance, set of all points in space, the same distance from the center. And a hemisphere is half a sphere. So if we were to draw, I always draw a circle and then I try to make it look three-dimensional. Right, and there's the point. So everything on this sphere is the same distance from that center point, and it's in space instead of in a plane now. It's not flat. The hemisphere, it's half of it. That's my best drawing of a hemisphere. So here we're going to look at the difference between a circle and a sphere. Circle the words that are different. Well, obviously circle and sphere. A circle is a set of all points in a plane that are the same distance from a given point called the center. A sphere is a set of all points in space that are the same distance from a given point called the center. Plane and space. A circle is flat, it's in a plane, it's two-dimensional. But a sphere is in space, it is three-dimensional. Draw the figures described below. A circle with center C and a radius of 6 centimeters. A sphere with center S and a radius of 6 centimeters. I want you to do this now. Remember, this is flat, and this is trying to make this look three-dimensional. You don't have to measure, just write the radius. Surface area of a sphere. The surface area of a sphere is, okay, well, imagine we've got this center, the circle right here. You can fit 4 of these on the outside of the sphere. So remember, to find the area of that circle, you do r squared pi. That's going to give you this circle. Well, if we take that and we put it on the outside, we would need 4 of them to cover the entire surface. So it is 4 times pi times the square of the radius. This is surface area. This is 2 dimensions again. We studied surface area a while ago. We're going to do volume in a moment. Find the surface area of the sphere. All right, so surface area equals 4 r squared pi. 4 of those circles fit on the outside. The radius here is 8 squared pi. All right, so 8 squared is 64. 4 times 64. If you want, at this point, you can put this whole thing in your calculator. Or you can leave it in terms of pi. So that would be 256 pi inches squared. Or you put the whole thing in your calculator, right? You can say 4 times 8 squared times pi. Get 804, round to the nearest whole number. 804 inches squared. Because it's the surface area. Now here, notice our diameter is 10. That means the radius is 5. You've got to watch out for that. Our formula is 4r squared pi. So 4 times 5 squared pi. Well, maybe you know that 5 squared is 25, and 25 times 4 is 100. So you can leave your answer as 100 pi if you want, or you can put that in your calculator. You get 314 centimeters squared. Right? Watch. 4 times 5 squared pi, 314. Okay, now it's your turn. Do these now. Don't forget your units. This is just like example 1. using the formula 4r squared pi. And notice here they gave you the diameter, so make sure you find the radius first, then put it in the formula. Now we're doing volume of a sphere. How much can this sphere hold? Not how much is on the outside, but how much can it hold? And for that, we use the fraction 4/3. And we have to do r cubed because we are in the third dimension now. And we're going to do volume. It's three-dimensional. So it's 4/3, the product of pi and the cube of the radius. All right, for the surface area of a sphere, okay, so that was this formula, 4r squared pi. The radius is squared, and the units are, well, when we do surface area, our units are always squared. Volume, oops, that should be a V. Our formula for volume of a sphere is 4/3 r cubed pi. Well, the radius is cubed in this example, and when we do units for volume, we also make them cubed. So that's one way to kind of remember which formula goes with which. So the volume of a sphere, volume equals 4/3 r cubed pi. Write the formula, now I plug it in. Volume equals 4/3 2 cubed pi. You can leave it in terms of pi or you can put it in your calculator. So let's check it out. Right, 4/3, you can just do 4 divided by 3 times 2 cubed. Right, and then you can put pi in there. Or 10.6667 pi. I like to leave that as a fraction. So I'd leave it as 32/3 pi. But you don't have to do that. You can just put this whole thing in your calculator and figure out what it is. So for example, you just go right from here to here. So 4/3 times 2 cubed times pi. 33.5. It says round to the nearest whole number. That would round up to 34. 34 feet cubed. Here we go again. 4/3 r cubed pi. But notice this time we only have half of a sphere. So we need to divide this by 2 at the end. So 4/3 5 cubed pi divided by 2. If you want to leave in terms of pi, you put all those numbers in your calculator. 4 divided by 3 times 5 cubed. Then we could divide it by 2 right now. I like to leave it as a fraction. So I would leave this as 250/3 pi. But you can go right from this step to this step. I'll show you. 4 divided by 3 times 5 cubed times pi divided by 2. 261.79. That would round up to 262 inches cubed because we're doing volume. You don't need to write down this step if you don't want to. Same thing over here. Estimate the air in a beach ball that has a 12-inch diameter, round to the nearest whole number. Well, we're talking about the inside, how much it contains. So we're talking about volume here. So first thing I do is I write down the formula, 4/3 r cubed pi. Well, my diameter is 12, it tells me. That means my radius is 6. So 4/3 6 cubed pi. Let's just put that all in our calculator. 4/3 times 6 cubed times pi. 905. We'll round to the nearest whole number. That's what it says. 905 inches cubed. So beach ball, right, an inch cubed, a cubic inch looks kind of like this. So this beach ball holds 905 of these. Seems like a decent sized beach ball, but that's what this means. All right, now it's your turn for the checkpoint. Find the volume of the solid. Notice this is a hemisphere, so you need to do half or divide by 2. Notice here they give you the diameter is 18, so make sure you find the radius first. Do this now. Watch your units. This is volume. So your units are going to be cubed. Volume equals 4/3 r cubed pi. This is M cubed, signing out.